Welcome back on C-Square. In this video clip, we're gonna look at absolute value function and graphs. And the first graph I'm gonna talking about is absolute value of x, and I'm gonna graph this by using a table. And I'm gonna do this table vertical, and I'm gonna pick some number, and I'm gonna start with 0. And if you take a look, 0, if we plug 0 in, absolute value of 0 is 0. Then I'm going to pick two more numbers, one less than 0, which is -1. Absolute value of -1 is 1. And one larger than 0, greater than 0, 1. Absolute value of 1 is 1. So now we're going to graph these 3 points. Oops. We're going to graph these 3 points. 0 and 0, 1 and 1, 1 right, 1 up, -1 and 1, 1 left, 1 up. And ladies and gentlemen, this is the absolute value of x, the graph of absolute value of x. This is the parent graph of all absolute value. You can see the same thing on the slide. And you notice there is a difference between absolute value of x and y equals x. This graph is a V, y equals s, x is a line that bisects quadrant 1 and 3. Okay, we're going to do the graph for the second function here, y equals absolute value of x minus 4. And again, I'm going to start with 0, then I will have 1, -1. These three values are good enough for graphing this absolute value graph. When x is 0, we end up with absolute value of 0, which is 0, minus 4, -4. Here we're going to end up with absolute value of 1, which is 1, minus 4, -3. Absolute value of -1 is 1, minus 4, also -3. So again, we can plot the points, and we should get something like this. What is the difference between these two graphs, between the one we just did it and the one that we did it in the previous slide? If you notice, the new one went down 4 units. Why? Because we subtracted 4. Okay, you can see that also in this other picture. And again, we can use a table here, 0, 1, and 2. I'm sorry, 0, -1, and 1. And we're going to get something like this. The graph moved 2 units up because we add 2. So now we look into this guy here. And we ask ourselves, yeah. So let's discuss first about two more transformation. Whenever you see something like that, the graph will move right. Okay, you can use a table also, but just a piece of advice, the table should start with 1 and then go to 0 and 2, and you're gonna get a nice V that will be something like that. It's gonna be moved to the right 1 unit. And also we can have something like this. When we add the quantity inside of the absolute value, this graph is going to move the graph left 2 units. By saying this, we kind of cover all the basic rigid transformation. So basically now we can look to this equation, y equal absolute value of x plus 2 plus 3. That tells us 2 units left, 3 units up. So that graph will be 2 units left, 3 up, this one. And you can grab this one also using a table. In the table, I'll advise you to start to -2, then -3, and -1 will be good enough to get that graph on the right bottom. You can see more transformation here. The first one, yes, is going to move 2 right because of x minus 2 and 1 up. The second one, the one on the bottom, 1 right, 2 down. Okay, let's talk a little bit about this type of function. You see the difference is we have a number in front of absolute value of x. So the number is 1/2. If we use a table, which I'm going to do it now, I will suggest you to go number like 0, -2, and 2. Okay, why this 3 number? 0, it's a good one to start most of the time on any function or any equation, and 2 and -2 here, those are even number, and in fact there are multiple of 1/2 of 2, and it's gonna work nice with that fraction 1/2. So if we put 0, we get absolute value of 0, which is 0 times 1/2 is 0. Then if we use 2, absolute value of 2 is 2 times 1/2 is 1. You see, that is one of the reasons we want to have even number, multiple of 2 in this case. -2, the same story, absolute value of -2 will be 2 times 1/2 is going to be 1. So look at here, this is the graph you get, and hopefully you notice that the red graph is wider. We call that vertical compression. The left and right side of the graph is pushed down towards the x-axis. We can do the same technique for graphing this gentleman. We're gonna get a skinny graph, I would like to call vertical stretch. And this one, we still have a 2/3, a -2/3 in fact, which is less than 1. That will be a vertical compression, and it's going to be flipped down because of the negative sign. And this problem is a summary of all the transformation we did. This tells us 2 right, so that vertex from the parent graph 0 and 0 is going to move 2 right, 4 up. So this is the so 1 2 1 2 3 4. This is where the vertex is, and then we need to use the 3 we have here to give how wide, to show how wide it is. My suggestion will be move 3 up, 1 to the left, 3 up, 1 to the right, and you should have a nice graph like this. You see it now here, and also you can see the parent graph, and you see the red one is a result of transforming the parent graph. If you enjoyed this video clip, don't forget to click the like button and come back on C-Square. Thank you.